Using the law of sines, we need to show that in a triangle ABC, A times cosine of B minus C over 2 equals to B plus C multiplied to sine A over 2. So we'll start from the left hand side. Here we have A times cosine of B minus C over 2. Let's also define the law of sine. So let's say we have a triangle ABC, then the side opposite to angle A, which is represented by BC, we're going to denote it by the letter A in lowercase. Then consider angle B, the side opposite to it, which is AC, we're going to denote it by the letter B in lowercase. And angle C, the side opposite to it, it will be AB, so its side will be represented by C. Then let's specify the law of sine. The law of sine states that the ratio of side A to that of sine of the angle opposite to it, which will be A. So this ratio is equals to the ratio of side B to that of sine of the angle opposite to side B, so that it will be angle B, equals to the ratio of C over sine C. So this is the law of sine. So what we'll do in our case, we will assume that these three ratios are equals to a common constant lambda, so that we can represent A as lambda times sine A. Then B value will be equals to lambda times sine B, and C value, that will be equals to lambda times sine C. So let's begin. So we have A here on the left hand side, so we can replace that A value with lambda times sine A. So this will be multiplied to cosine of B minus C over 2. Now we're going to use the fact we have a half angle formula. So we know that sine theta, the half angle formula, is given by 2 times sine theta over 2 multiplied to cosine theta over 2. So these are the formula that we're going to use here. So let me note it down. So in place of sine A, then you can use the half angle formula to get 2 times lambda multiplied to sine A over 2 times cosine of A over 2 multiplied to cosine of B minus C over 2. Now we know that sum of the interior angles of a triangle, that's pi. That means pi radians. A plus B plus C equals to pi radians, which means that A can be also expressed as pi minus B plus C. So let's replace this value in place of this A here. So we are going to get 2 times lambda multiplied to sine A over 2. So we're not going to work with the sine A over 2 because we needed sine A over 2. So we will only replace this A value with pi minus B plus C whole divided by 2 multiplied to cosine of B minus C over 2. Let's further manipulate. So we have 2 lambda times sine A over 2 times cosine of pi over 2 minus B plus C divided by 2 multiplied to cosine of B minus C over 2. Now we know for a fact that whenever we have cosine of pi over 2 minus theta, so that's equivalent to sine theta. So that means we can replace cosine of pi over 2 minus B plus C over 2 with its equivalent sine, and then we'll get sine B plus C over 2. So that means we will now get lambda multiplied to sine A over 2. We're going to use the 2 here, so 2 will get multiplied to, so this cosine will now get converted to sine. So we have sine B plus C divided by 2 multiplied to cosine of B minus C over 2. Now we have a standard formula here. So this is equivalent to, so we have lambda times sine A over 2. So we have sine B plus sine C. So sine B plus sine C, so that's equals to 2 times sine B plus C over 2 times cosine of B minus C over 2. Now what we can do, we can replace the value. So in place of sine B, we can have B over lambda. And in place of sine C, we can have C over lambda. So B over lambda is sine B and C over lambda is sine C, which gives us lambda multiplied to sine A over 2 multiplied to, so we have B over lambda The sine c will be c over lambda. We can factor out 1 over lambda and cancel it out with a lambda outside. So we'll finally get b plus c multiplied to sine a over 2. And this is the expression on the right hand side. So hence we have successfully showed that a times cosine of b minus c over 2, that's equals to b plus c times sine a over 2 by using the law of sines.